Hello, welcome everyone. My name is Dr. Phil Winder and I'm the CEO of Winder.AI. Welcome to these events where we talk about the work that we do. As you know, we are experts in RL, ML and MLOps, and we use these events to talk about some of the work that we've done for some of our clients. Today, I am very pleased to share with you a story from Enrico Rotundo, and where he worked on one of our clients to help them figure out the world of Buildpacks. And we came to the conclusion that actually Buildpacks are a really useful tool for an MLOps platform team. As usual, if you want to ask any questions throughout the video, then please pop them in the chat window of the tool that you're watching in, and I'll jump in with any questions to ask Enrico as we're going along. So yeah, feel free to add any questions there. Without further ado, I'd like to introduce Enrico here, and he's going to take you through the presentation. Thanks.
Hi everyone, and thank you, Phil. Yep, let's just start. So today we're talking about Buildpacks, the ultimate ML container. So briefly, the schedule for this webinar is just introducing what problem solves Buildpack, specifically around the ML platform world. I'll introduce what Buildpack is and give you a quick demo as well. Well, so what's the problem at stake? So during machine learning development, typically you have a data scientist working on some sort of environment and writing their machine learning code. And typically this is then shipped to a remote ML platform that takes care of building and running it. Now, the process of submitting a job as such is essentially very complex. So packaging an ML project adds multiple steps on along the journey. That goes beyond just writing the code. It starts really from writing, touching your code requirements that can be just from simple Python pip libraries to system level packages. Then you also need to, if you want to exploit GPU acceleration, you'll need to provide your package with support for that as well. Sometimes this can be very, very complicated. On top of that, you might also need to manage credentials to access data or private library repositories. And what we typically see is that these projects, when packages through the Docker files, see a huge growth in numbers of Docker files attached to the project. Typically, people just write one file per target platform, and that adds really tons of complexity. On top of that, recent Apple Silicon processors changed a little bit and introduced some issues while developing Docker files on a M1 equipped machine and shipping that to a remote x86 cloud resource. So Docker themselves, they actually say that they're fully aware of the problem, and they say that support for ARM architecture, which is the technology behind M1 processors, is should be regarded as best effort only. So it's not still fully supported yet, and that can really be hiccup throughout your ML journey. And then, of course, maybe it's a Friday end of the day, and the security teams comes in and say, well, you need to add also, we need to roll out security patches to all of our containers. Well, that's also a serious problem that holds you back from just doing your data science work. So let's take a look at how ML platforms approach this, and see also what really modern platforms could do through Buildpacks. Well, typically, so in many platforms, you just bundle up your code in a tarball file, which is just a single item you can ship remotely. Problem with this is its size can really, really grow terribly. And of course, this becomes a problem when you need to transfer that over the wire. It's also a repetitive process, a bit annoying. Well, as I said previously, you could also do a Docker file. So in a Docker file, the problem with that is essentially it requires Linux and system knowledge, and it has the Mac M1 problem that I mentioned before. It essentially that really spans beyond what your ML job is really. You'll have to invest some time in it. Well, we've seen many cloud ML providers rely on pre-containerized runtimes to solve the problem for you, which results in a very long list of options for the end user. These essentially are Docker images that they make available for you, where all sort of Python libraries have been installed, and so that you can have like just an off-the-shelf experience. Unfortunately, that also results into a very large runtime images. It's really okay for the Jupyter notebook developments, but as soon as you need to do and bring in more complex requirements, that's a problem. Well, so what modern ML platforms have been doing is something slightly different. So it's allowing essentially the user to submit their code, and they will pick that up and automatically install dependencies and package everything into whatever container they have under the hood, and this in principle should make things easier. Now, from the platform perspective, this means a thing that they'll have to implement in auto discovery or some sort of logic that understands your ML project and knows how to build it, how to create it and run it. So this, of course, becomes a complex task whenever you want to support multiple languages, multiple package managers, and GPU requirements, and so on. By the way, Phil made a great video about this topic. So if you're interested in learning more about this, just head to Winder.AI/blog. You'll find a great presentation there. Now, let's try to put Buildpacks into the picture here. I'll get to what Buildpack is in a moment, but let me first say Buildpack is able of handling virtually any dependency in the Python world and beyond. So it does pip, conda, apt-get, and so on. It supports Python, Java, Scala, many other languages, and essentially it allows a platform team to centralize the management of image rollouts, ensuring containers, well, the via Docker registry, but without really bothering the end user with any task related to that. By the way, it runs, so it is capable of building your ML projects on Kubernetes. So it is capable of scaling out very, very well. The principle behind this talk is that we really believe that modern ML platforms should allow users to focus on their code, and the platform can take off the heavy lifting. So what are really Buildpacks? And then we'll look at that and see how they can be useful. Well, Buildpack is a system that is capable of turning your project code into a container automatically with no user input. It does that through an auto detection system that is capable of inspecting your repository and understanding what language you use and what libraries you use. On top of that, it relies on a modular system made out of Buildpacks and supports multiple languages. As I said, it creates, at the end of the day, it creates a Docker container. So it's fully reproducible. I don't see my slide deck anymore. Yeah.
Yeah, that's fine. I'm just doing stuff fancy.
Thanks. And well, on top of that, it adds also caching. So it's something very interesting. Started back in 2011 by Heroku. And what I said, the Buildpacks reusable components. I'll introduce you to them in a minute, but there's also a Buildpack registry that it's some sort of like GitHub, repository for exploring and reusing these components. Now, back to the data scientist journey. Now they've write an ML project, and this time they ship it to an ML platform powered by Kubernetes and Buildpacks. What happens is the platform is going to inspect its code, and the process is split into two stages. So we have on the left-hand side of this diagram, we have a build environment, and then we have a run or app environment. Now, if we focus on the overall picture here is basically it is, as I said previously, this is based on Docker containers for your build and run images, but this is hidden under the hood. So the pair of these two images composes a stack that is maintained by the MLOps platform team and stored in the internal Docker registry. And when the user submits a job to this platform, the platform takes it from there and runs a life cycle. I'll show you the details in a second in the next slide. But what we need to understand here is that the build process will run through a number of Buildpacks. And these are specialized software units that solve specific problems, such as maybe installing, your Python runtime and your dependencies and so on. All these Buildpacks will produce artifacts that are stored into layers. This will be then handed over to the runtime image. But let's dive quickly deep into what a life cycle is, which is a number of steps run by each of the build pack. It's a little bit complex, but on a high level, there are two important phases. So each build pack run a detection phase, which is essentially a script that looks into your code base and figures out whether she is suitable to build your project. It does that by checking a number of things, and then if that is a green light, the ball is passed along, and a build script will be triggered. I'll show you that in the live demo in a moment. Yes. So when each build pack is done, building their own slices of your project, this will be provided to a final stage that is in charge of packaging and enriching a run image with first your application code, and then these layers that will ship with the build artifacts. Let's see how this looks like in practical terms. Well, so I have a simple PyTorch application that I want to compile and run. And what we see here is, well, we have a train.py file. I'll show you in a second. A pip requirements file listing pip libraries, and a proc file. This is going to be used to set up the container entry point. Now, the machine learning code is really simple. I'm just using PyTorch to train a linear model. By the way, it's just a self-contained script in the sense that it downloads its data set as it goes, which means when we'll run it, this will complete the training process autonomously. Well, what I'm showing on screen is, well, I'm using the Buildpacks CLI or pack on the build command, where I'm essentially pointing to the application folder, and if you see the arguments, I'm actually pointing to a specific builder. Now, a builder is is an item that references to a number of things, including the stack that I talked about before, and to a number of build packs that the builder creator package for us. In this case, I'm using Paketo Buildpacks, which is open source. It works very, very well. So what do you need to do to build a project like this? Just do pack build and run. First stage, yes, it's pulling the build and run images. These are just Docker containers, but they're hidden under the hood, like the user won't see them. And then it runs a detection phase. Here, the system is electing suitable build packs for my project. So if you look to that list, we'll see it detected it is a Python project with some pip requirements and a proc file as well. This happens very fast, by the way. And then maybe the more time-consuming step is what I'm going to introduce now, the building phase. The building phase here is essentially a step where it runs the build script of each of those build packs listed on the screen that went through the detection phase. And if you look at the bottom of the screen, it's going to install the Python 3.9 runtime. And then among other things, it also detected that I had a pip requirements file. So it's doing that, and it's actually also showing that the output will end up to a specific layer, which is a location in the file system. That will be then carried over to the runtime, to the run image at the end of the build. I'm using also a proc file, which instructs the system to run Python 3 and train.py as a container entry point. And then the very last stage is what I said. Buildpacks here is essentially adding all these slices to the final application images. After that, our application has been compiled into a container. It's available on our Docker registry. And by the way, rebuilds can happen automatically upon source code changes, or even stack images changes. So the system is capable of creating fresh containers in a reactive manner. Yeah, these were hidden. So Buildpack can do actually more than what I've shown here. So off the shelf, you have support for a vast array of package managers.
Actually, Enrico, I think just before we move on from there, I think it's worth sort of jumping in with a couple of questions, actually. A couple of clarifying questions that I think that I have that I think people might find useful. So just to recap the process, the Buildpacks are effectively responsible for detecting, I guess triggers is probably not quite the right word, but things that will trigger that Buildpack to run. So if you've got a requirements.txt, it'll trigger the pip file and so on and so forth. I guess the question there then is, how would I customize? How would I add my own Buildpack to add my own, enterprise specific requirements in there? Say you've got some like security requirements or security scanning or something that needs to happen. Or packages that need to be installed in order to make them agreeable to the security team. How would you actually go about inserting that into the process?
Well, so essentially anybody that can write just a bash script can achieve that. In fact, a Buildpack is nothing else than two scripts and a metadata file that describes that. The only limitation you have is that, your Buildpack detect and build code is capable of working, is allowed to be working only on the user space. So you're not allowed to modify, system OS files and parts of the file system. But it's really, really, up to you how you implement that. Of course, there are tons of these Buildpacks available on GitHub, so that's a great source of inspiration as well.
Okay, all right, perfect, thank you.
Yeah, so I was saying, so Buildpack can really just off the shelf supports most package managers out there, and we tested it with system level libraries, which can be installed through some tricks that are actually working well and allowed by the system, just require a little bit of care. So we tested it with OpenCV and all sort of NVIDIA libraries for GPU training. As I said, you can also do pre and post build scripts, maybe to prefetch some data or to connect to your private libraries or repositories or registry. Well, it's really flexible as a system. Now it's not part of this talk, but it also creates bills of materials for you, which is a file, a manifest file that describes exactly what's in a container, and this is done basically for free. I think it's also very interesting to mention that with Buildpacks, you can also create a custom build flows that can react to the output or the artifacts created by some other build pack upstream. So for instance, you could write easily a build pack that installs TensorFlow version 1.5 based on the CUDA 10 version that was installed by some other build pack that was triggered upstream. And similarly, you could also read your custom configuration files that maybe can enable some part of your ML platform and act accordingly.
Yeah, so just to jump back in again there, I think that's a really important point. So you're saying that you can use this technology to be able to handle different layer dependencies or dependencies between the layers. So dependencies from like, an OS level to a library level, or from like a hardware level to an OS level and so forth, and basically fork off to install different dependencies depending on what's detected underneath. Is that right?
Yeah, that's exactly right. Yep.
Yeah, cool. Okay, thanks.
Yeah, well, so so we reached the end of the presentation. From my side, just to recap a little bit, we have so we believe that this is the ultimate ML container system, really because it really lets the user focus on their code. Increasing data scientists and ML practitioners' productivity, and it provides this hands-off approach to just project compilation, supports lots of language runtimes, dependencies, configurations, and I think it's also very important that you'll enable your platform team to manage the Docker images that will be used throughout the organization, throughout the platform, in a centralized manner. And well, last but not least, builds can happen on Kubernetes, so that's super scalable. So that's me. Well, feel free to reach out for anything really.
Awesome, thank you very much, Enrico. That was great. Yeah, of course, if you're interested in getting any help with any Buildpack related work or ML related work that relates to Buildpack, then definitely reach out. Check out our website, Winder.AI. You can reach out to us on email, either Phil at Winder.AI or Enrico at Winder.AI. I think so. I haven't seen any questions pop in, but there's a couple more minutes if you'd like to get any questions in just before we leave. I think I have a couple myself though, Enrico, if that's okay. So I'll just hide the presentation for now. I might need to go back to it. I think one question I have though is we've talked about how Buildpacks work from an operations perspective, like how they're structured, how it gets built, how it turns into a container. But what does it look like from a user perspective? Imagine I'm a data scientist and I'm actually consuming the Buildpack. What would the data scientist actually do on a day-to-day basis?
Well, so well, let's assume you develop your project on on some machine. What you really do is so you make sure that your code runs, produce your Python or whatever R files, and then what the ML platform will probably supply you with is a client tool. You can use through your terminal that will have some common like ML platform space submit job, and you point it to your project directory. And then ideally the platform will just take it from there. So what you transfer over the wire is just text files really, and not the whole bundle.
Right. Okay. So you're saying that you would submit your files to be built. When I guess we're talking at some scale here. Obviously, you could just build them locally on your own laptop or whatever. But yeah, if you imagine that you're in a CI pipeline or something, and it would submit, or I guess it could even build it in the CI pipeline, couldn't it? Yeah.
Yeah, definitely. Actually, there's a number of integrations with all sort of CI tools. And that will just trigger and send the builds over to the Kubernetes cluster.
Yeah. Okay. Cool. Yeah, I think the only other question I had was early on. We had a couple of slides about the different phases that are happening. So I guess my question is where do those phases happen? Let me go back to the slide. I think it was 24 or something. Yeah, here we go. So where do these phases actually happen? Where do they execute? Is this inside the service that is actually like hosting the build?
Sorry, so this happens fully remotely. If I go back a couple of few slides, well, essentially this happens fully remotely, like within the ML platform side, specifically within the build environment container. But this is absolutely even from the user, so that you want see that.
Yeah. Okay. All right. I get it. And is there any versioning capability built into Buildpacks? Would you ever would you ever request a specific Buildpack version to build your code, or would you let the platform team kind of decide what should be built at any particular time?
Ideally, you want to have, well, rather than Buildpack, maybe you may want to give the end user control to what builder they use. But really, if you look at the open source builders, they are really well built, and they cover, they're constantly updated. They cover lots of build packs. So I didn't mention it in the presentation, but essentially you can create group of build packs that allows you to make the system modular and cover multiple cases, multiple languages, and so on. So I think I wouldn't expose that to the end user really.
So in these public builders, if you imagine you're working with the Python builder, something really popular, is the intention that you always use the most recent version of the builder? Then you don't say that I want to use an older version of the builder.
Well, well, not necessarily, because if I can go back to my first demo slide. Well, yeah, this one. So what? So the very last argument here is this environment variable where I'm instructing the Python build pack to use a specific Python version. So they support, to some extent, passing arguments for these kind of use cases.
Yeah, okay, but you're specifying the things, you're specifying the versions of the things inside the eventual container, as opposed to specifying the version of the actual build pack. What does that colon base mean after the builder parameter?
Well, so it's just that Pacato Builder comes with different. Well, they publish three different builders. They have a tiny, a base, and a full images. And the difference really is that lies in the build image. Or in the build image that essentially has. So in the full version has all sort of C libraries pre-baked into, while in the tiny version as not, and also supports a slightly smaller set of languages. These of course will change the image pulling time, so maybe less data to transfer. But yeah, they do have different. They're not really different versions. They just cover use cases to different extents.
Yeah, it's almost a little confusing because it's the same syntax as like a tag, a container tag. So it's almost like they're implying there's different versions of that container there, but it's not meant to be used like that. It's like select different functionalities. Okay.
Exactly.
We've had a question from a viewer. What scale of organization or project makes sense for build packs to become useful? Good question.
Yeah, good question. So I think so this is useful for any organization that decided to build a either an internal or public platform, ML platform as a software, as a service. So we're talking, well, I would say like fairly larger scale, especially because I think this really makes sense if you run it on a Kubernetes cluster. So it's not really just about build pack. That would be only one part of the system.
Yes, I think one thing I would agree with that answer, and I think it comes down to the fact that if you're at the point where you do have an MLOps platform team and you are attempting to abstract out some of the work that your data scientists might need help with, that would be the point where it starts to become useful, because you've got different layers in the organization then, and those different layers will mandate different things. The infrastructure team will mandate some things, security team might mandate something else, and you want to add capabilities on top of that. So this is the situation that would be a really good match for build packs. If you're interested in that, I did a presentation a while ago about when you need an MLOps platform team, i.e. like what size of business, what size of number of data scientists and so on, is it useful to have an MLOps platform team in the first place. So check that video out if you're interested in learning more about that. But yeah, I think basically as soon as you've got an MLOps team, you should start considering to use build packs. All right, that's fantastic. Oh, we've got one more. Sorry, we might as well stay here since we're having fun. Can I mix build packs in Docker? Can I mix build packs in Kubernetes? There's limitations. Container tech use Docker, container D. They live happily together. So I think the question is about whether you can leverage different container runtimes within build packs. I don't know if you can necessarily use them together. That might not make sense, but I could imagine a situation where you maybe want to build like a proper Docker artifact, or use container D to build it, for example. So yeah, I guess the question is, have you seen any examples that are using different technologies for the underlying container format?
I've mainly seen in Docker-related container technologies, but the Buildpacks is built really to support any system that implements the open container interface. So essentially, like any standard container implementation that would be supported.
Right. Okay. So anything that is CNI compatible could be used there.
Yeah.
Okay. Great. And does the the Kubernetes service that you talked about, K-Pack, I think it was called, does that have any opinions of what container runtime it uses? I assume it's not Docker. It's probably container D, I would guess.
Yeah, I'm not sure about that, but
no worries. All right, awesome. I think we'll stop there. We've gone over time a little bit, but I'd like to thank you, Enrico, for an excellent presentation, and thanks for all that useful information. And yeah, once again, if anybody else has any remaining questions, then feel free to reach out over email. So for now, I'll leave you there. Thank you very much, everyone. Goodbye.